This is the white belt video for class 2. We're doing loops and conditionals, or conditionals and loops. So I'm going to start off. There are a couple of activities here. There's the exercise around web application. So you definitely want to take a look at that. Web application, very briefly, is an application that is hosted on the web. I'll talk about that in another video. Today, what I want to do is talk about conditionals and loops for a bit. Once we're done with this video, please look into the other two videos, one for the exercise, one for the activity. I'm going to pull up really fast. I'm going to pull up this document. This will be in with the resources there with the other files. And what I want to do is talk about, we're going to start with conditionals. So a conditional is a way to run code sometimes, conditionally. So if the conditions are right, we will run that code. If the conditions are not right, we will not run that code. So let's take a look for a moment. I'm going to zoom in a little bit here. Scroll over here. Let's imagine we have this workflow. So if you're not familiar with workflow diagrams, these are basically nodes. So the squares are nodes where something will happen. The diamonds are decision points. And then based on the results, we will do something else. So let's start off. Let's imagine we need to get an employee. Once we get that employee, we want to ask the question, is the employee part-time? If they are part-time, true, then we're going to set their PTO to 0. In other words, they get no paid time off. Otherwise, if they're not part-time, false, then we're going to set their PTO, their paid time off, to 80 hours per year. So this is a decision tree that maybe some business is deciding. They're basically saying all part-time employees get no paid time off, all full-time employees get 2 weeks a year. And then once that's done, either way, the hourly wage will be $30 an hour. So very simple flow. But basically we've got, okay, once we get the employee, we want to set their PTO, their paid time off, to either 0 or 80 depending. And then their hourly wage is always 30. So this is the decision tree. This is the flow that we want to try to code up. So let's look at some conditionals here. We're going to start off with an if block. If else, or else. These are all permutations of the if block. So looking here, what we're going to do is we're going to start with getting the employee. So we're going to call that the same that we did on the top node. We're going to put that into a variable, employee, so we can access that information later. Then on the if, so this is the decision tree. If employee is part-time, then we set PTO to 0. So again, going back over here, true, PTO equals 0. Otherwise, false, that's the else block, then we set employee PTO to 80. So this simple if else takes care of the true and the false statements here. So if true, we set the PTO to 0. If false, otherwise, we set it to 80. And either way, we set the employee hourly wage to 30. So this is the code that represents this basic decision tree. Let's look at another one. So in this decision tree, what we're going to do is we're going to get our employee. We're going to ask if they're part-time. If they are part-time, we're going to set the PTO to 0. Either case, we set it to 30. So in this case, let's imagine for a moment that everyone's employee records already have 80 hours of PTO. And what we need to do, we're now supporting part-time employees. We didn't have part-time employees before. So now what we need to do is for any of those employees where it is part-time, we're going to set the PTO to 0 because part-timers don't get paid time off. So that's basically what we're going to do here. False just doesn't do anything. It just goes to the hourly wage. So again, let's look at the code. We're going to get the employee. Then we're going to say if they're part-time, set the PTO to 0. And then set the hourly wage. So there is no else block in this case. There's nothing we need to do if it's false. We just skip. So this simple if block will take care of this particular flow. So if true, we're going to set to 0. Otherwise, if false, or if it's true, we always set the hourly wage to 30. So again, this is the code with a conditional, in this case an if block, that will represent this particular workflow. Let's look at another example. So this one's going to be a little more complicated. We're going to say get the employee. Are they part-time, true or false? So just like we did before. Let's take the true case first. So let's start with they are a part-time employee. The next question we want to ask is, are they probationary? So a probationary employee, maybe it's the first 60 days, first 90 days. That would be a probationary employee. Maybe it's their first little bit of time. If they're probationary and part-time, they get 0 paid time off. If they're not probationary, so maybe it's after that introductory period and they're part-time, we're going to give them a week off. So we're actually going to give part-time employees a week of paid time off per year. If it's not part-time, they get 80, regardless of whether or not they're probationary. Then any of those cases, we always set the hourly wage to 30. So all of these employees are getting $30 an hour. The question is, if they're probationary, they get 0. If they're part-time and not probationary, they get 40. Otherwise, if they're not part-time, they get 80. So a little bit more complicated. Let's look at the code and see what this looks like now. So once again, we're going to get the employee. If the employee is part-time, this is the first decision node up here. If the employee is part-time, now we're going to look at the second decision node. If probationary is true, then employee PTO is 0. That's that bottom box that my face is covering. Otherwise, employee PTO is 40. So this is the inner decision tree here for is probationary. This is the outer decision tree. If they're not part-time, that's the else block down here, they get 80 PTO hours. So again, an if else block, we've got a nested, this is called a nested if else block because it's nested inside another if or else block. So we've got an if with a nested if else to take care of this forking logic. We call it forking because it branches out kind of like a fork with the tongs on a fork. And then finally, in all cases, we code up hourly wage is 30. So again, this is the code that represents this conditional. All right, so now let's look at another way to look at this, another way to do these if-else blocks instead of nested ones. We're going to look at a slightly different thing. So it's slightly different logic. So we get the employee. Now the first question we ask is, are they probationary? If they are, it doesn't matter if it's full-time or part-time, they get 0 PTO. So slightly different than the last example. So all employees that are probationary get 0. Otherwise, if they're part-time, they get 40, and if they're full-time, they get 80. Very similar to the last flow, except that probationary full-time employees still get 0 PTO. Whereas in the last one, that's not the case. Full-time employees always got 80 PTO. So this is a slightly different logic. Again, in all three of the cases, hourly wage is set to 30. So let's look at the code here. Instead of doing nested if-else, which you could do, I instead did this as if-else, if-else. So if employee is probationary, again, this is the top decision node. If they're probationary, then no matter what, they get 0. Otherwise, if is part-time, here's the second decision node. If they're part-time, they get 40. Otherwise, they get 80. So very similar logic, but I used a slightly different structure. You could use a nested if-else in this case. Similarly, on the previous example, you could have done this with an if-else block. So whether you do nested else if or if else, or you do an else if block in the middle, and you can do a bunch of else ifs, it does not matter. They both work. It's 6 of one, half a dozen of another. A lot of it is style and readability. But that's the idea with this particular case. All right, let's look at another example. So at this point, we're going to switch up our conditional. We're going to use, instead of if blocks, we're going to use switch statements. Switch statements are also conditionals, but they work a little bit differently. So let's imagine we're going to get our employee, and then we need to say, okay, what is the type of employee? So instead of just asking true false questions, we're going to say, go to the employee type and tell me the type. The type is going to be one of these three. They're either going to be a probationary employee, or a full-time employee, or a part-time employee. They can only be one of these. So employee type is going to be one of those values. So it's not a simple true, false, or yes, no. True, false, yes, no is great for if blocks. When we have something that can have more than two values, a true and a false, that's a great place to put a switch statement. So a switch says, depending on which route I go, I'm going to do different logic. So if they're probationary, they get 0 PTO. If they're full-time, they get 80 PTO. And if they're part-time, they get 40 hours of PTO. Again, in all three cases, hourly wage is set to 30, just like we did before. So let's look at a switch case statement now and see how it's different than an if-else given this particular condition. Once again, we get our employee. Then we're saying switch on employee type. So I'm going to go back to, I'm going to zoom out a little bit. Notice we're saying, what is the employee type? Switch on employee type. So this is, the switch statement is what matches the decision tree node. So we're saying switch on employee type. If the case happens to be probationary, or the case happens to be part-time, or the case happens to be full-time. So oftentimes you'll hear switch statements referred to as switch case statements because we have the switch keyword and the case keyword. Cases are specific instances or cases of a value for the whole switch. So the switch is the outer block. The case is a particular block inside the switch. So that's the relationship between switch and case. So we're saying switch on this, and then the case, each of the three cases are these three values. So if the case is probationary, then set the PTO to 0 and break. The break is very important. That says don't keep executing more code inside the switch. Break out of the switch. So this says we're done. If we don't have the break, some languages don't allow this, but some languages will then say employee PTO is 0. If there's no break, it'll then set employee PTO to 40, which obviously in this case is not what we want. So the break statement tells the program, don't execute anything else in this switch. It breaks out of the switch statement. So we execute the case, get to the break, and then that's all the code that would execute. If, however, the employee type is part-time, we're going to set the employee PTO to 40 and then break. So if they are part-time, this is the only code that's going to execute. And then finally, if they're full-time, we'll set the employee PTO to 80. And again, this is the only code that executes. There is the equivalent of an otherwise or an else inside a switch statement. It's called a default. So instead of case employee full-time, you would see default colon. So default would be the keyword. There's no value. It's just default colon. And that almost always applies at the end. In fact, I can't even think of a time or a language that would support default previously. So default is basically always at the end. So that's a switch statement or a switch case statement. So it allows us to set up multiple branching logic for these different things. You could do this with an if else. You could say if employee type equals probationary, else if employee type equals part-time, else if employee type equals full-time. So you could absolutely set this up as an if-else statement. The switch statement just becomes, especially when there's multiple cases like this, a little cleaner and a little easier to read. It's not a right or wrong. You have different styles, different choices for doing things. So that basically takes us through the conditionals, and I'm going to run through loops as quickly as I can. So loops, a loop is basically iterating over something. Maybe it's a collection of things, or maybe it's a sequence of numbers. So let's look at, for a moment, disregard the code because I want to focus on the workflow diagram. Let's look at this workflow diagram for a moment. Imagine we have 5 numbers, 0, 1, 2, 3, and 4. And what we want to do is we want to go through each of those numbers, 0, 1, 2, 3, and 4. I is just a variable. So it says I is 0, and then this one says I is 1, this one says I is 2. So I is our variable, but basically we have the numbers 0, 1, 2, 3, and 4. That's the collection of numbers. So it's the first 5 numbers starting at 0. What we want to ask is, if I mod 2, which gives us the remainder, equals 0, if that's true, then we want to display is even, which is true. Basically, this is our detection for if a number is even or not. Otherwise, if it's not equal to 0, that's false. We want to display the text to the user is odd. So we're running through these. So we should expect 0 divided by 2 has a remainder of 0. So this is true. 1 divided by 2 has a remainder of 1, which is false. So it is odd. So 0 is even. 1 is odd. 2 we should expect to be as even. 3 we should expect to be as odd. 4 we should expect to be as even. So this is the workflow that we're trying to code up. So again, we've got a sequence of values up at the top. For each one of those, we're going to do some conditional check, and then we're going to display something. This loop up here, these values, this is where the looping construct comes in. So now let's zoom in. Let's take a look at the code. We're going to use a simple for loop. So let me look at the numbers up here. We're going to say for var I, so my variable I, so I just use I in each of these cases. You can call the variable anything you want. I'm going to choose I. I is very common if you're using for loops with numbers. We just say I. So for var I, the for loop is separated by semicolons. There's 2 semicolons that give us 3 parts, part 1, part 2, and part 3. Part 1 is called the initialization. So we're going to say, where do we initialize I? I could initialize I to 0. I could initialize I to 4. But I could theoretically initialize I to 2 or 1 or 3 or anything I want. But in general, going from 0 to 4, it probably makes the most sense logically to either start at 0 and just add 1 each time, or to start at 4 and subtract 1 each time. So for this particular case, I'm going to start at 0. I'm going to say start at 0, and each time I want to add 1 to get the next value. And that works. That'll work to get us through these 5 numbers. So we'll say for var I equals 0. That's our initialization. We're choosing to start on the left number. The second part is the condition. We do this to make sure we keep going. If this is true, we enter the loop and we execute what's in the loop. If this is false, we're done with the loop and we skip over. So what we're saying is I needs to be less than 5. If I get to I equals 5, 5 is not part of my list, so I don't want to execute that. So I is 0, and while I is less than 5, we're going to keep going. So 0, 1, 2, 3, 4, all of those are absolutely less than 5. I could have also written this as I less than or equal to 4. That works too. So in both of those cases, we would have the same check to make sure that we go from 0 to 4. The last is the increment. This is what we change each time through the loop. I++ is basically saying take I and add 1 to it. That's what plus plus is. This is shorthand for I plus equals 1, or I equals I plus 1. Those are all 3 different ways to write the same way to increment a number by 1. I++ is just the shortest way to do that. Whatever I was, you add 1 to it. So basically, to read through this for loop, we say we start at 0. We're going to add 1. So we actually do the last part next. We add 1 each time through the loop as long as I is less than 5. That's what this structure says. So this structure here, these three parts, gives us these 5 values up top. That's what the for loop is doing for us. Then inside the for loop, it iterates through and executes the code. So we start off again, and so let's break this down. We'll start off with for var I equals 0. Now the next thing that happens is it does a check. Is I less than 5? Yes, it is. 0 is less than 5. Therefore, we're going to enter the loop. We're not executing part 3 yet. We're going to come back to that. So we do part 1 and then part 2. Then we go into the loop. I is 0, so we're going to display is even. We don't have the else. We come to the end of the loop. Then we go back to the top on the for loop. The next thing we do is we execute part 3. So I plus 1, so 0 plus 1 is 1. Then we go back to part 2. Is 1 less than 5? Yes, it is. Then we enter the loop again, and now we're going to check our if. If I mod 2 is 0, it is not. It's going to display is odd. It goes to the end of the loop, comes back up, goes to part 3 again. 1 plus 1 is 2. Is 2 less than 5? Yes, it is. It runs through the loop again, and so on and so forth. So the way the code works with a loop is it will execute part 1, then part 2. And if part 2 is true, it goes into the loop. If part 2, no comment. If part 2 is false, it actually skips over the loop and goes to the next line of code after the for loop. So to go part 1, then part 2, then the loop. Then part 3, then part 2, and the loop. Then part 3, part 2, loop, 3, 2, loop, 3, 2, loop, so on and so forth. So the part 1 is only executed the very first time through the loop. Part 2 is checked after either part 1 or part 3. And part 3 is executed each time at the end of the loop before we go back in. So again, part 1, part 2, code in the loop. Part 3, part 2, code in the loop. Part 3, part 2, code in the loop, so on and so forth. That is the basic structure of a for loop. So a lot is happening in just this one line of code. Let's look at another example. So in this case, we're going to take the numbers 0, 2, 4, 6, and 8. So now we want the even numbers starting at 0. We don't want to go to 10, but we want to start at 0. Again, I could start at 8 and go down, or I could start at 0 and go up. If there's another clever way you can think of, you could do that as well. But basically, we just want 0, 2, 4, 6, and 8. Those are the numbers we're looking for. We're now going to see which of those is evenly divisible by 3. So I should say, so again, is divisible by 3 or is not divisible by 3. So 0 is divisible by 3. 2 is not divisible by 3. 4 is not divisible by 3. 6 is divisible by 3. 8 is not divisible by 3. So it should be divisible by 3, not, divisible by 3, not. That's what we're expecting to be for the output. So let's take a look at the for loop here. There are several ways to write this particular for loop. Here's how I chose to do it. So again, simple for loop, 3 parts. We're going to initialize to I equals 0. Again, I could have started with I equal 8. What that would mean is instead of I plus equal 2, starting at 8, I would say I minus equal 2. I'm going to subtract 2 each time. It also means my condition needs to change. So we're going to say I starts at 0. I increments by 2 each time, 0, 2, 4, 6. And we go as long as I is less than 10. So let's talk about a few different ways I could have written this differently. First off, I less than 10. I also could have said I less than 9, because that would result in the same thing. I could have said I less than or equal to 8. That would also be the same thing. I could even say I is less than or equal to 9. We'll never actually equal 9, but that would still be true. So this particular condition, I could do it as I less than 10, I less than 9, I less than or equal to 9, or I less than or equal to 8. All of those would satisfy the conditions. And then I plus equal 2. Again, I could have started at I equals 8. This loop would look dramatically different. So I'd say for var I equals 8, I greater than or equal to 0. I minus equal 2. So notice this no longer is 10, it's 0 because I need to stop once I get to 0. It could also be I equals 8, I greater than negative 1, I greater than negative 2, I greater than or equal to negative 1. Similarly, lots of different ways I can do this particular conditional, but going from 8 down, I absolutely need to turn this into minus equal instead of plus equal. I subtract 2, and then I need to make sure that I stop once I get at 0. Beyond that, it's a simple conditional. I'm not going to go through that. Let's look at one more example. This is a different kind of loop. So instead of numbers, let's imagine I've got 4 names: John, Jennifer, Alex, and Sarah. So out of these 4 names, what I'm asking is, does the name start with the letter J? If it does start with the letter J, I want to display starts with J. If it doesn't, I display does not start with J. So a quick look: John starts with J, so yes. Jennifer starts with J. Alex does not start with J. Sarah does not start with J. So very, very simple. So in this particular case, a for loop isn't going to serve me as well. What I'm going to do instead is use a for each loop. So we're going to initialize names as a collection or array or a list of string values. So this is going to be an array or a list of John, Jennifer, Alex, and Sarah. So notice the double quotes. These are string objects. So names as a collection or a list or an array of strings. My for each loop here is quite a bit different than the for loop. I'm saying for each var name in names. This name could be anything I want. I came up with name. Var is a keyword, in is a keyword, names is the variable we described here. This name is whatever I want it to be. So this could be for var each, for each var a, for each var first name, for each var apple. I can call it anything I want. It does not matter. I'm calling it name because it seems to make semantic sense, both because the plural is already names and these are conceptually name objects. So I just chose the word name. You don't have to choose the word name. So it's for each var variable in some list variable. That's the structure. Each time through the loop, each time there is still something in the loop, it's simply going to use that as the first one. So this is going to start with John. It's going to say, does John start with the letter J? And then yes, it does. Then it goes to the next name in the loop, Jennifer. Yes. Alex, no. Sarah, no. So that's a for loop, a lot simpler. This works if you're not having to iterate over numbers and you already have a collection of objects. But if you are needing to iterate over numbers, the for loop is an easy way to construct a sequence of numbers so you can iterate over those. That basically takes you through conditionals and loops. I do recommend doing a little bit more research to solidify this. These are the foundations of dynamic programming, so these are very important concepts. Definitely take a look at the class and the activity and the exercise videos. So we've got the web application exercise and we've got the conditionals and loops activity that will give you a lot of practice with these particular things. Good luck.